recording on this thing, sorry. Okay, I just started it. So number 12, slightly different. Always start with the vertical asymptotes, because those are usually easier to figure out.
Okay.
Where's the vertical
Is
asymptote?
it 2 again?
No. Remember, the vertical asymptotes are usually determined by division by 0.
Oh, so
In
is
other
it
words, we're looking for what happens to cause this thing to be division by 0. It's when x equals 3.
3? Okay.
In other words, that's the one thing that x can't be. So that immediately tells us our domain. What's our domain?
All real numbers but 3.
Let's see if I can figure out how to write this. All reals, is that the double R? All reals except x not equal to 3. I don't know. Okay.
Close enough.
Close enough. You know what I mean. And the range?
Is it all real numbers except for 2?
Yes. But more importantly, the horizontal asymptote is at y equal 2.
Right.
In other words, the first question is, let me close my camera out here because it's saying the internet's kind of slow today, I think. I've been having troubles with my computer keeping up. So once you've defined your vertical and horizontal asymptotes, and again, this is a horizontal asymptote because this part of it is 0. In other words, if we were graphing just this part, the horizontal asymptote would be y equals 0, and it's being shifted up 2, so it's up to there. And so what's the range? All reals except y not equal to 2.
Okay.
All right. Number 13. I keep looking to see if they've done anything even different.
Yeah.
And they have. They're doing something different on every problem. Not much, but a little bit. So the vertical asymptote, first question.
So it's -3?
Yes. And the horizontal asymptote.
-2?
Mm-hmm. And the consequences of this negative sign does not really affect the asymptotes.
Okay.
It does affect the graph
Mm-hmm.
in the sense that, let's see, when x is positive, I think it puts everything in the second and fourth quadrants like this because of that negative sign. But it doesn't really matter because it doesn't affect the domain and range, and they didn't really ask us to graph it. To determine whether it was the second and fourth quadrant, I would plug in some values for x and see whether I'm in the second quadrant with y.
Okay.
But notice that it doesn't affect the domain and range. What's the domain?
All real numbers except -3.
And the range?
All real numbers except for -2.
So notice that that wasn't affected by which quadrants this hyperbola is in. Hyperbolic graph. All right, now we got something different.
Okay.
Now, when you have a variable in the numerator and the denominator, it affects the horizontal asymptote, but the vertical asymptote is still only, what can't x be?
3.
Now, to figure out the horizontal asymptote, first of all, we have to realize that the highest exponent in the numerator on the variable is 1, same exponent in the denominator, and therefore the horizontal asymptote is the ratio of their coefficients, which in this case are both 1.
Okay.
So the horizontal asymptote is at y equal 1.
Okay.
Now, another thing about horizontal asymptotes is that the graph can actually go through horizontal asymptotes. It can never go through vertical asymptote. In other words,
Okay.
I might have a graph that looks like this and then approaches that.
Okay.
And it could even do the same thing over here. We wouldn't know that until we plot some points and figure out what this graph does, or we'd have to investigate it a little further. But I'm just giving you a heads up that horizontal asymptotes can be crossed, vertical asymptotes cannot. So what's the domain on this?
All real numbers except for 3.
And the range?
All real numbers except for 1.
Well, we don't necessarily know that. In other words, if this is one of those things that crosses the horizontal asymptote, then it's going to be all reals.
Oh.
How can we tell? And I don't know whether they've gotten this deeply into the subject or not. You got to think.
Probably not, because I just started.
Okay, so you have not had any graphs that cross the horizontal asymptotes.
Not, yeah, at least not that I...
Okay, now I think you're right. I'm looking at the chapter now and all the graphs they're showing. So it's okay to assume for the time being that we're not going to cross the horizontal asymptote, and the graph's either going to look like this and this, or in the second and fourth quadrants of my asymptotes. So this would be correct for domain and range.
Okay. I guess we can move on to the next page and
Let's do
graphing.
one more problem.
Okay.
I want to make sure you can do this one, and then we'll go to the next page. What's the vertical asymptote?
So 2 or -2?
No, make the denominator equal 0, and whatever the x value is, that's the vertical asymptote. In other words, I'm going to solve this equation. 3x plus 1 equals 0.
Oh, so it's -4.
It's negative 1/3.
Right. Or, I mean -1/3. I'm sorry.
Which means there's your horizontal asymptote right there, your vertical asymptote at negative 1/3. And what's the horizontal asymptote?
2/3.
Yes. Ratio of those coefficients. And again, you know your domain and range. All right, let's look at the next page. Okay, now it's asking us to graph the function. Let's just make sure we didn't miss anything. You don't want to do 21, 22, and 22? Or 20, 21, and 22? Those should be relatively easy to do.
Yeah, we can.
Okay, which one, especially since we don't have to write anything,
Uh-huh.
which graph is number 20?
Um,
You can tell it almost instantly.
oh, B.
Okay, which one is 21?
Um, C.
And therefore 22 is A. Okay,
Uh,
let's look at 23. So they want us to graph it and then state the domain and range. Okay, that's good. We've been kind of doing that already. Where are my asymptotes? It's always the first thing you want to do to graph something is
okay.
lay out your asymptotes. Excuse me 1 second. What the heck? Hello? Okay. Okay, so where are our asymptotes?
Um, so
Vertical one
is
is where?
is the vertical 1 or 0?
It's x equals 0. In other words,
Okay.
this line is x equals 0. The y-axis is x equals 0. And the horizontal asymptote?
4.
No. Remember, okay, if there's no variable in the
Oh,
numerator,
0?
yeah, it's always 0. This part of it's always 0 if there's no vertical shift or anything.
Mm-hmm.
So there's our two asymptotes. We know this function is hyperbolic in nature. There's nothing going, there's no shifts of any kind, and there's no negative numbers, which means it's always going to be first and third quadrant.
Okay.
When I draw this, these lines are approach your asymptotes as you go to infinity on the right and left, and as x goes to 0, you go to infinity, y goes to infinity, unless x is going to 0 from the other side, and then y goes to negative infinity. So the domain
Is all real numbers except for 0.
and the range,
All real numbers except for 0.
okay. Notice that there's no way to make y 0. If we look at this
Right.
function, there's no value I can put in for x that makes y equal to 0. The only way y is ever going to be 0 is if there's a 0 in the numerator, or if the numerator has a possibility of being 0. Okay, so now we got this one. Vertical asymptote,
3.
actually it's x equal 3
Okay.
because it's a line. So it's not just a point, and a line is defined by, in this case, x equal 3. And what about the
Okay.
horizontal asymptote?
Y equals 1.
Oops. Okay, now to graph it, let's see if we can give you an easy way to graph this. Automatically, I would be inclined to think that it would be first and third. How can we tell? Well, let's put in a value of x greater than 3 and figure out where the y plots. And if it's in this area, we'll know the whole thing is first and third.
Okay.
So when I put in a value of 4 for x, what do I get for y?
3 or 5. 4. I mean.
4. Okay? In other words, if x is this point right here, y is 4, which is right there. There's x equal 4 and y equal 4, which means that point is in the first quadrant. Therefore, we're looking at this kind of graph. And that's all you really need is to figure out one point. As long as you're dealing with linear hyperbolas, and not something like a y equals 1 over x squared, then you can do that. Because y equal 1 over x squared is first and second. But as long as we're dealing with powers of 1, we're going to be either first and third or second and fourth. And once you figure out just one of them, you'll know the rest.
Okay.
What's the domain?
All real numbers except for 3.
And the range?
All real numbers except for 1.
Except for y equal 1, yeah. Okay, let's look at 25. Vertical asymptotes?
X equals -5.
Horizontal asymptote?
Y equals -8.
And which quadrants are we in? And by that I don't mean the quadrants with regards to the x and y axis, I mean the quadrants with regards to the asymptotes, which I don't have fully drawn on here. Let me pick it up there now. And this is at -8. So how do you figure it out?
So do we pick a point bigger than -5 or something?
Pick a point near this, because notice that that's what we want to find out, is we want to find out a point. Actually, let's see if it's in the first quadrant. So pick a point to the right of -5. In fact, why don't we pick a point over here, then we'll be absolutely clear where it is. Let's pick x equal to +5.
Okay.
So when x is equal to +5, what is y equal to?
So that's 4/10 minus 8.
So 4/10 minus 8. Which side of that horizontal asymptote is that on? This side here or this side here?
The first side.
The first or the fourth quadrant? Yeah,
The first?
Right, because this number is this number is -7 6/10, correct? Yeah. So when x was equal to 5, y was on this side of the asymptote, which means this is this kind of hyperbola. Kind of surprising to me. I would have thought that that negative sign, I guess you can't always base it on the fact that there's a negative sign there.
Yeah.
Okay. I maybe could have picked a little more convenient point for x. Let's see, what if I had picked x equal -1? Notice that when x is -1, I've got -4 over 4. So I have -1 minus 8. I have -9. Aha. This thing is below there. How is that possible? Unless it crosses the horizontal asymptote and then comes up back under it. Wow. I've either made a mistake here somewhere or this is confusing to me, because I don't know why they would give it to you like that. Here, let's do something. Let's pull it up on my graphing calculator. Wolfram alpha. And this is the function, which one are we doing? Minus 4 over x plus 5. Minus 4 divided by the quantity x plus 5 minus 8. It is in the second and third quadrants.
Oh.
Notice that if I put the cursor right here, where the vertical asymptote is and the horizontal asymptote is, right there, that it's in the second and the fourth quadrants. The only question is why is this x-axis labeled the way it is? On Wolfram alpha. Why are these negative numbers? This makes it look like, you see what I'm seeing here?
Yeah.
It doesn't make any sense. Why they're, no, I'm confused. Could be going on here. This could be a key point for you. How did we get this point? Did I do my math wrong there? Let's erase this. Trying to figure out how we ended up with being in this first quadrant. Because when I picked the point x equals minus 1, we were in this fourth quadrant, which is where we're supposed to be. Well, how is it that when I picked a positive x, this is minus 4/10.
Yeah.
Minus 4/10 minus 8 is minus 8 and 4/10, which puts it on this side of that horizontal asymptote. So I made a math error. Otherwise, the first value of x I picked gives me my proper positioning. In other words, now I know that it's this and this. So we did it right. I just made a math error, which confused everybody. Okay. 26 doesn't look particularly special. Nor does 27. I mean, do you see anything about them that would be confusing?
No. It's like the same.
Nor 28. Let's look at 29. And are you just covering 9.2 or are you covering more also?
No, I said 9.2 to 9.4. So
that's what I thought. Okay. So we don't want to spend our whole session on these.
No.
Let's forget 29. There's nothing hard about it.
Can we do like 36 or something?
Yeah.
Like down below?
Yeah, okay. So we got y equals minus 3x plus 10 all over 4x minus 12. For graphing it, we need a vertical and a horizontal asymptote. Where's the vertical?
It is it 3?
It's whatever x makes that denominator 0. And the horizontal asymptote?
Negative 3/4.
And let's find a point.
So do you just pick like any point, or like do you have to look at like?
We're looking for points. In other words, you wouldn't want to pick x equals 3.
Right.
And we're expecting it. Actually, this negative sign, I'm not sure that there's any expectations. So the
Okay.
key is pick a point to the right of 3, like
Okay.
4. You don't need to go very far to the right.
Okay.
4 will work. Is all we're looking for is which quadrant one of these things is in, and then we'll know which quadrant the other half of it's in.
Okay.
So when x is 4, what is y? So what is y of 4? Numerator is minus 2. What's the denominator?
-2.
When I plug in x for 4, what do I get in the denominator?
Oh, the denominator.
Bottom half.
4.
Okay. So, in other words, y should be -1/2 when x is right here. Well, -1/2 does put it in that first quadrant. It is above the horizontal asymptote. -1/2 is closer to the origin than -3/4 is. In other words, that point was 4, -1/2, which means I can say that this is one of these kind of hyperbolas.
Okay.
What's the domain?
All real numbers except for 3.
And the range?
All real numbers except for -3/4.
Okay. Let's go to the next section. All right, now we're dealing with higher powers of x. Let's look at question 4. Can I go in to start on?
Yeah.
On page 550.
Uh-huh.
Y equals 6 over x squared plus 3. What's the first thing we need?
To find the asymptotes.
The vertical asymptote? Yeah, and then the horizontal, but where's
So you have to factor it out, right? Or no, you can't.
What makes the denominator 0?
3.
No, actually nothing.
No,
Nothing.
nothing.
Right?
Uh-huh.
In other words, x can be anything I want. Hold on a second. Okay. The computer must be performing slowly. Notice there's no value for x, where x squared is equal to -3.
Right.
So there's no vertical asymptote. That means x can be anything we want. How about a horizontal asymptote?
Is there no, I don't know. Is there no horizontal one either?
Can y be negative?
Yeah. Or
How?
no.
No,
it
it
can't.
can't. Because the denominator is always positive. The numerator is always positive. In fact, what is the smallest value that y can be?
1. Or
2.
0.
2. X can be 0. So when x is 0, y is equal to 2. When that's not the, let's see. What happens when x is 3? What is y?
6 12, so it's 1/2.
Okay, so y would be right there. And when x is -3, what would y be?
1/2.
So this is symmetrical about the y-axis.
Mm-hmm.
Whatever it does over here, what about when x is 100? What is y?
Mm.
There is a horizontal asymptote here. Y equals 0 because there's no value, there's no variable in the numerator, and there's a
Mm-hmm.
variable in the denominator. Whenever you get that, you have a horizontal asymptote of 0. Y is never going to be able to be 0, no matter what x is. So the y values are going to approach the horizontal asymptote as x goes to infinity, and same way in this direction. So that's what
Okay.
that looks like. Let's just double check. 6 divided by x squared plus 3. Yeah. Notice they give you two different scales when they graph it. And
Mm-hmm. Yeah.
they both are going to approach. This one doesn't really show the horizontal asymptote very well. It doesn't make it look, it looks like it's an upside down parabola. But this one does show it peaking at 2. That's the biggest that y can ever be, and that happens at x equals 0, and then gradually approaching the horizontal asymptote.
Okay.
My graph wasn't quite as pretty. But. All right, let's look at 5, which is definitely different. What's different about 5 over every other one we've done?
There's an X on the top and the bottom.
We've had that before, but this is the first time where the x on top has a higher power than the x on bottom.
Yeah.
So to graph this, the very first step is to divide it, is to do that long division. Surprised they're having you do that. This is rather tough. Let me see. Yeah, they continue to have difficult ones below this. Okay. So we have to do this long division and work with the result. Notice what I do here. I put in a dummy variable for x because there's no power of x. And when I'm going to do long division, I'm going to need this dummy variable here. It doesn't matter whether it's plus or minus. I could make it plus. Do you know how to do this long division?
Huh.
First, you start only with dividing that into that. What's that?
2.
What is x divided into x squared? What's this? X squared over x.
Oh. I don't know. 2. 1.
Subtract the exponents. When you have same base, different exponents, subtract the exponents so you get x to the 1.
Okay.
So x goes into x squared x amount of time. Now you multiply this by both terms. Well, we knew that was going to be x squared. We just divided it into it. Plus x. Now you do just like long division. We subtract. Well, this is 0 here. And then we have 0 minus x gives us a minus x. We carry the minus 4 down. Now we do the same thing again. We divide x. What's x into minus x?
Minus x.
We have x dividing into minus x. What's that?
Just negative x. 0.
What's the exponent on that? What's the exponent on that? What's x divided by x?
0.
1.
1. 1.
Anything divided by itself is 1. 4 divided by 4, 6 divided by 6, 1/2 divided by 1/2. Anything divided by itself is 1, so having one of these be negative just means it's a negative 1. So x goes into minus x minus 1 time. Now I multiply this by this. Well, minus 1 times x is minus x. Minus 1 times 1 is minus 1. Now when I subtract, I have a minus 4 minus a minus 1. That gives me minus 3, and I'm done. So I have a remainder. My remainder is minus 3 over x plus 1, the divisor.
Okay.
You always end up with the remainder over the divisor. So now I can say that this division yields this. X equals x minus 1 minus 3 over x plus 1. So now I know how to handle that. No, I don't. Just a second. You're kidding me. They don't give you any in the section that are like this, where they have to divide it into it? Yes. Number on page 548. They show you one similar to this. All right, I see what they wanted us to do here. All right, let's go back and rethink this whole thing. Obviously, you're not to a point yet where they do it this way. That results in an oblique asymptote. And the oblique asymptote is that x plus 1. The way they want you to do this is by factoring the numerator into x plus 2 times x minus 2, because the numerator is difference of squares, and then graphing that. Vertical asymptote?
1 or negative 1?
Negative 1. There's no horizontal asymptote. When the power of the variable is higher in the numerator than it is the denominator, you might have a oblique asymptote, which you do whenever it's exactly 1 higher, and the equation of the oblique asymptote is what you get when you divide that into it. And what we got was x minus 1. Well, if I graph that oblique asymptote that goes through minus 1, and it has a slope. So there's the oblique asymptote, which I got by dividing x plus 1 into x squared minus 1. The first part of that result was x minus 1 plus some remainder. Well, you can forget the remainder. This defines the oblique asymptote. And then just graph that as a line. If you were graphing y equal x minus 1, that's what this line is right here. In other words, this line right there is y equal x minus 1. And then the vertical asymptote is at minus 1. So this thing is somewhat hyperbolic in nature. It can look like one of the two following ways. This is going to look, the graph of this, it's going to look like this. It's going to either look like this, where it approaches those asymptotes. See where it's drawn? It's in the first and the third quadrant, so to speak.
Yeah.
Or it can look like this in the second and fourth quadrants, so to speak. So we have to determine which it is. So let's erase those lines I just drew. And see if we can figure out where it's at. What's this function? This is, which one are we working on? Oh, number
5.
Yes, excuse me. So it's x squared minus 4 over x plus 1. So if our goal is to graph it, we have to figure out where it is. Actually, this is a hard one to graph because it's hard to find the vertex of this thing. But we can at least figure out approximately where it's at. I'm not sure how accurate your graph has to be. What value would we try for x to see where it falls in this region?
About
0.
Like 1?
About 0, right there.
Okay.
Plug in x of 0, what do you get?
0.
When you plug in x of 0 into this, what is this whole expression equal to?
Oh. -4. So is it 4 or -4?
-4. So y of 0 equals -4. So -4 looks to be down here, which would suggest that the curve is in the second and fourth quadrants. Well, let's plug in an x very close to, let's see, how can we verify that? If we plug in an x that's up here somewhere, we'll know. We should know. So let's plug in an x of 9. What is y of 9 equal to? 81 minus 4 is 77 over 10, about 7.7, which puts it where? I don't know. If 9, when x is 9, y is 8, so 7.7 puts it right there. In other words, I can look at this asymptote, this oblique asymptote, and I can tell that if I plug x equal 9 into that, y is 8. So this point right here is 9 comma 8 on the asymptote. Well, when we plugged in 9 for x, we got 7.7, which means it's below that line. So indeed, that confirms that we're looking at something that would graph like this.
Okay.
And then the other part of it would be in the opposite area. And that's not bad. Those graph pretty easily. Where it becomes difficult and where you would be unable to figure out exactly how to graph it is if we ended up with our graph like this. Because now the most important points of this graph are the y-coordinates of these vertexes, so to speak. And those are not easy to calculate. You probably are going to have to use your graphing calculator, graph it on your graphing calculator, put the trace on that, and figure out where that value is. Otherwise, there's no way to state the range for this function if you end up with this situation. We were actually in the second and fourth quadrants, the way we drew it. Or the way this function is in the second and fourth. The first would be this quadrant here, I suppose, if you were going to number them. All right, let's see. We just have a minute or two left. Is there anything else? Let's look at matching those two graphs. Let's look at the three questions at the bottom of that page. Match the graphs for me. It's pretty easy to do. Which one is 20?
Is it A?
Yeah, because A has a horizontal asymptote at 1.
1.
21, where's the vertical asymptotes on 21?
Oh, 2.
Plus and minus 2.
Yeah.
Well, both the B and the C have vertical asymptotes at plus or minus 2. So notice that graph B has an oblique asymptote in there. They didn't draw it in there, but can you see it?
Yeah.
Where do we get oblique asymptotes? When the denominator is a lesser degree than the numerator.
Right.
So 22 would have to be B. Only 22 has that oblique asymptote.
Okay.
And 21 would be C.
Can we go over 32 really quick? Because I don't know how to do the one with the cube roots in it.
Sure. Not that different, really. What's different about the denominator? Is there a vertical asymptote?
Yeah.
Okay, where's it at? I've got to solve this equation.
Yeah.
Okay, so 4x cubed equals 32. So x cubed equals 8. So x equals what?
I don't.
2. The cube root of 8 is 2. So our vertical asymptote is at 2. Is there a horizontal asymptote? Notice that it wasn't plus or minus 2. The solution to that is 2 only. Negative 2 cubed is negative 8. So the cube root of 8 is positive 2. So there's only one vertical asymptote. Where's the horizontal asymptote?
Is it 3/4?
So once you get that far, graphing it now, you're 50-50. You know what I mean? In other words, once you get the asymptotes defined, then you're going to be right half the time if you guess there and there. And if you see any negative signs, guess the second and the fourth. But right off the bat, I'm drawing this like this. Now, if we have time, if you're taking a test, that's what I'm going to do if there's speed issues. But if I have time, I'll check. Okay, let's pick a point to the right of 2.
3.
Okay, so y of 3 equals what? Let's just go through the numerator. What's x cubed? What's 3 cubed?
9.
3 squared is 9. 3 cubed is 3 times 3 times 3. So it's 27 times another 3 is 81 plus 1. So it's 82 in the numerator. And what is 3 cubed again? 27 times 4 is 108. So we have 108 minus 32, which is 76 in the denominator. So that number is slightly greater than 1. So when x is 3, y is above this, because this number, this is 3/4. So
Okay.
it's in other words, it's there.
Mm-hmm.
That tells me that it's in this first quadrant of these asymptote lines. Once I know it's the first quadrant, then it tells me I drew it correctly.
Okay.
Okay? So that's pretty much what you're going to be doing. Where I'm seeing weakness, really, on your part is in your algebra, not your graphing. It's solving what makes this equal to 0.
Right.
You need to improve your skills there. Otherwise, you got no chance on when you get to the graphing of these.
Okay.
So I'm not sure what you need to do to improve your skills there, but just practice working through this. What I would do if I were you when I see something like this, I would absolutely write it out like this and set it equal to 0 and solve it.
Yeah.
And then this is what you need to be able to solve. If you can't solve that, that's a problem. That's a big problem. Okay? So anyway.
Okay.
I hope that's been helpful. It probably is better than nothing, but good luck on that test tomorrow.
Okay, thank you.
Okay, Morgan. Bye-bye.